Hello everyone, welcome to my channel. In this video, I'll explain you how to write tie-set matrix for the given network graph. For the network graph shown in figure, first let us write number of nodes, number of branches, number of twigs and number of links. Number of nodes small n equal to, let us count the nodes 1, 2, 3 and 4, and number of branches small b equal to, we have A, B, C, D, E and F. So total number of branches equal to 6. Number of twigs T equal to n minus 1, where n is the number of nodes. 4 minus 1 equal to 3. Number of links L equal to B minus n plus 1. B is the number of branches 6 minus small n 4 plus 1 equal to 3. We have identified number of nodes, number of branches, number of twigs and number of links. Now let us see step 1. Step 1 is to select a tree of a given directed graph. You can draw one possible tree from this network graph. Tree is a subgraph which consists of all nodes but no closed paths. So let us put the nodes 1, 2, 3, 4. I would like to choose this as tree. Tree is a subgraph which consists of all nodes but no closed paths. Let me write related branch currents F, E and D. Order of tie-set matrix is L by B, where L is the number of links and B is the number of branches. From the previous formula, we have calculated L equal to 3 and B equal to 6. So order will be 3 by 6. It indicates the matrix will have 3 rows and 6 columns. And tie-set matrix will be indicated with the letter B. And number of tie-sets equal to number of links. Earlier we have calculated number of links as L equal to B minus n plus 1. We got 3. So number of tie sets equal to number of links, that equal to 3. Let us see how to form a tie set. Tie set is nothing but fundamental loop or fundamental tie set, anything we can call it. So let us see how tie set will be formed. I am drawing the tree whatever I have drawn earlier. Node 1, node 2, node 3, and this is E, D, and this is 4. Okay. Fundamental loop or F loop or tie set is a loop which contains only one link and one or more twigs. I will just close this link. I'm going to take this as this is a link which is able to form a loop. This is called as fundamental loop. From the given graph, this is A. So this is the direction of current. Let it be I1. Fundamental loop or F loop or tie set is a loop which contains only one link and two or more twigs. This is what you can see in this loop. Okay. Here we have two twigs and one link. And another thing is direction of the current in the loop is always should be in the direction of link current. Here link current is in this direction. So in the same direction loop current need to be taken. One condition is a fundamental loop or F loop or tie set is a loop which contains only one link and two or more twigs. And second condition is the direction of loop current should be in the direction of the link current. Okay, this will be tie set 1. I will just indicate the branches involved in this tie set 1. Branch currents A, E, and F. Now I'll draw tie set 2. Let me redraw tree again. 1, 2, 3, 4, F, E, D. Okay. Fundamental loop or F loop or tie set is a loop which contains only one link and two or more twigs or one or more twigs. Here you can see this is a fundamental loop which contains one link and one or more twigs. And from the given graph, the direction of branch current is here in this direction, it is a B. And the direction of loop current will be in the direction of link current. I'm going to call this current as I2. And I will call this as tie set 2. Branch currents involved here are B, D, E. Because in this loop we have B, D, and E. Next, third one. 1, 2, 3, 4, F, E, D. So F loop or fundamental loop or tie set is a loop which consists of only one link and one or more twigs. So this will become a F loop and the current flowing in this will be in this direction. It will be in the direction of link current. Let it be I3. And this is tie set 3 and branch currents involved here are C and D. Let us write the matrix now. Die set matrix is indicated with the letter B and order of die set matrix will be L by B. L is nothing but number of links, B is the number of branches. Earlier we have calculated number of links equal to 3 and branches equal to 6. So we can have 3 rows. The 3 rows will be loop currents I1, I2 and I3 and columns will be branch currents A, B, C, D, E, F. Die set matrix will comprise us of elements either +1, -1 and 0. According to tie set 1, if you see here, tie set 1, the branches involved here are A, E and F. You can see here A, E and F. The branch current which is in the same direction of loop current will be taken as 1. The branch current which is in the opposite direction of this loop current will be taken as -1. The branch currents which are not involved in this loop will be treated as 0. Here in tie set 1 we have A, E and F. A, E and F. Remaining elements will be 0 because they are nowhere connected to that loop. Check whether the direction is in the same direction or not. If you see here, A is in the same direction of I1, it will be +1. E is in the same direction of I1, it will be +1. F is in reverse direction because if you just consider this current will come in this way, right? So I1 current is in the opposite direction of this branch current F. So at F you should put -1. So we are done with first row. Coming to second row, This is a tie set 2. In tie set 2, related branches are B, D, and E. The current flowing B is in the same direction of I2, D is in the same direction of I2, whereas here E is again in reverse direction. So B, D, E. B, D, E. Whereas E is in reverse direction. That is the current flowing of E is in reverse direction of I2. So we will put -1. Remaining elements will be 0. Next, I3. For tie set 3, we have related branch currents C and D. C is in the same direction of I3. D and I3 are in opposite direction. So we'll just write 1 -1 and remaining elements will be 0. This is how we can write tie set matrix. Tie set matrix will comprise us of 3 elements +1, -1 and 0. Coming to the KVL equation of this tie set matrix is given by BVB equal to 0, where order of B is L cross B, and this VB is nothing but branch current matrix. The order will be B by 1 or B cross 1, and this, if you multiply these two matrices, we will be having here L by 1. Okay, here we have L cross B is nothing but, for this example, it is 3 by 6, this is 6 by 1, and this is 3 by 1. And we can write this as, I'm just writing B, which we obtained just here, 1 0 0 0 1 -1, 0 1 0 1 -1 0, 0 0 1 -1 0 0. And VB, this is 6 by 1, that is 6 rows 1 column. I'm assuming the branch voltages as VA, VB, VC, VD, VE and VF equal to 0 0 0 0. By writing the equations of this, we'll get, just multiply these two matrices B and VB. We can get VA plus VE minus VF equal to 0. And here you can see VB plus VD minus VE equal to 0. And here you can see VC minus VD equal to 0. These are the KVL equations obtained for tie set matrix. Next, KCL equations. It is given by IB equal to B transpose into IL. IB is nothing but branch current matrix. Order will be B by 1. And B is the tie set matrix which we obtained. When you do the transpose of that matrix, the order will be B by L. And IL is the link current matrix. Order will be L by 1. Number of branches here in this example are 6. Number of branches here are 6. Number of links are 3. So here also we have 3 cross 1. By rewriting this, we can write, I'm assuming the branch currents as IA, IB, IC, ID, IE, IF. And if you apply the transpose of that matrix, we can have the matrix as 1 0 0 0 1 0 0 0 1 0 1 minus 1 1 minus 1 0 minus 1 0 0 and IL link currents as I1, I2, I3. Earlier we have assumed loop currents or link currents as nothing but I1, I2, I3. By elaborating this, we can write the equations as IA equal to I1, IB equal to I2. Just I am multiplying these two matrices and equating with this matrix on the left hand side. IC equal to I3, ID equal to I2 minus I3, IE equal to I1 minus I2, and IF equal to minus I1. This is how we can write KCL equations. The steps we followed in obtaining tie-set matrices are: first, after seeing the network graph, you just write the number of nodes available in the network graph, then number of branches, then number of twigs t equal to n minus 1, then number of links l equal to b minus n plus 1. Then step 1 is to draw any possible tree which is obtained from the network graph. After that, step 2 is you identify the order of tie-set matrix. Order of tie-set matrix is given by L by B, 3 cross 6 here. And then identify how many tie-sets are possible. Number of tie-sets equal to number of links, that equal to 3 from for this example. Then obtain the tie-sets, tie-set 1, tie-set 2, tie-set 3. Tie-set is nothing but it is a fundamental loop or F loop which consists of only one link and one or more twigs. You just connect one link so that it will form a loop, and also make sure that the direction of this loop current is the same direction of this link current, so you should take in the same way. And even for other tie sets you follow the same procedure, and then you try to write the matrix. In matrix we'll have only three elements, either plus 1, minus 1 or 0. Plus 1 is nothing but whenever you find the branch current is in the same direction of loop current, you put plus 1. Whenever the branch current is in opposite direction of this loop current, you put minus 1, and the remaining branch currents you put just 0. By following this logic you can fill this tie set matrix. Then coming to KVL equation, we will have the equation like B VB equal to 0. Order of B is L by B, order of VB is B by 1, and obviously if you multiply these two matrices the order will be L by 1. And substitute each and everything, and I am assuming that voltage across each and every branch is V suffix A, V suffix B, V suffix C, D, E and F. Next, to write KCL equations, you write this equation IB equal to B transpose into IL, where order of IB is B by 1, order of B transpose is B by L, and order of this IL is L by 1. If you substitute all the things, we can get these equations. Even here, I am assuming I suffix A, I suffix B, IC, ID, IE, and IF. This is how you can obtain die-set matrix for any network graph given in the exam. That's all for this video. Thank you.